Okay, so a bag contains 7 gold dollars and five $5 gold pieces. All right. So, gee, that's weird, right? So I'll point out what I'm doing over here. I'm labeling things, and I'll point out what I'm labeling. I'm saying the gold dollars. I'm just going to call it X, and the $5 piece is Y. I got to keep track of that. So what are you doing? There's 7 of these things, right? So if I looked at the bag, the bag would look like 1, 2, 3, 4, 5, 6, 7, and then there would be 5 of those $5 pieces. One, whoops, two, three, four, five. Right. So a bag contains 7 of the X's and 5 of those Y's. If a person is entitled to draw 4 coins, so let's just count them up. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 coins. And what are they allowed to do? They're allowed to grab 4. Then the problem comes is there's ways to grab those coins, right? Now, they could pick all X's. That's one possibility. They could pick 3 X's and a Y. They could pick 2 X's and 2 Y's. Well, what else could they pick? They could pick 1 X and 3 Y's. They could also pick 4 Y's. All right? So let's do it. The probability of getting that, well, let's count it up again. How many there? There's 1, 2, 3, 4, 5, 6, 7. So 7, choose 4. Now, by the way, you don't have to write this down. You can say I'm picking 0 for those. I'm not going to write that down. But there's 7 of these, and there's 5 of these. If you want to, you could write down 5, 0. But 5, 0 is 1. All right? We'll do that computation, and I'll do it one step at a time. So let's see, 12, 4. That's going to be 12, 11, 10, 9, 8 factorial, and 4 factorial on the bottom. Kind of nasty number, isn't it? That's 5. 5 times 9 is 45. Times 11. That's 450. And 45, which is 495. By the way, I don't need to compute that again. So 12, 4, I'll write this over here, is equal to 495. All right? Now I'm going to do the top number. Get my eraser out. I got to do 7, 4 now. And 7, 4 is 7 factorial. 7, 6, 5. Well, you have 4 factorial. On bottom, there'd be 4 factorial, 3 factorial. 4 factorials cancel off. 3 factorial is 3 times 2, which is 6. So you get 35. So this would be 35. So the probability of this occurring is 35 out of 495. I want to highlight that for you. That's right over here. I'm going to move on to the next one, but I'm going to erase this one now. We're done with this one. I'll erase this. And I got to compute the next one. Let's write that down. So what do you get there? You're still picking 4 from the 12. But now you got 3 X's. Well, there's 7 X's. And you're picking 3. And of the 5 Y's, you're picking 1. Well, we've already done the bottom part. I'm not going to do that again. That's 495. I got to do the top. And what's top going to be? 7 factorial over 3 factorial, 4 factorial, times 5 factorial over 1 factorial, 4 factorial. Well, that isn't so bad. And I got to be careful about this. So you're going to get 7, 6, 5 over 6, which would be 35. And the 5 factorial over 1, 4, factorial is just a 5. So you get 7 times 25, which is 175. All right, let's just make sure we wrote that down. I got that done. Let me erase that. We're done with that. And I'm moving through the list. Let's do the next one, which is this, this guy over here. Well, I'm still going to pick 4 coins. And what are the successes going to be? Well, from the 7, you're going to choose 2. And from the 5, you're going to choose 2. Well, the bottom I've already done. I know that's 495. And what's 7, 2? That's not that bad. That's 7 times 6 over 2, which is 21. And 5 choose 2 is going to be 5 times 4 over 2, which is 10. So it's 210 over 495. Get my eraser out. Erase this over here. We're just going through one at a time. Let's do this guy now. Well, we still have 12. Choose 4. And of the x, we're only going to choose 1. So 7, 1. And of the 5 y's, we're going to choose 3. On the bottom, I've already done 495. 7 choose 1 is 7. 5 choose 3 is 5 factorial, 3 factorial, 2 factorial. So you're going to get, let's see, 10, which can be 70 over 495. Let me highlight that for you. Okay, let's erase. We got one more to do. And that last guy, all y's, right? Now, granted, I can't even remember what y is at this point, but that's not the issue. I'm just counting. And it's almost like I'm counting letters here. 12, 4. We're not going to pick any x's, but from the 5 y's, we're going to pick 4. So it's going to give us 5 over 495. Again, you may wonder why I'm not reducing it. I'm going to have to compute an expectation. So we also computed this over here. We got that done. All right, let's talk about value now. And this is where I got to go back and remind myself the value of these things. So the x's are worth 1. The y is worth 5. All right, let's talk about it now. So what's the value here? We're going to put the value down now, the value. The value of this one over here is going to be, well, each x is worth $1, so it's $4. We'll just call that V1. What's the value of the second outcome? Well, it's going to be 3 plus 5 is going to be $8. What's the value of this outcome? Well, 2 and 10, $12. What's the value of this outcome? Well, 1 and 15, which is going to be 16. What's the value of this outcome? 20. All right, so let's write this down. The value total, I'm sorry, the expectation now. $4.95 is the denominator. Let's do one at a time. 4 times 35. That's 120, and 20, 140. 8 times 175. Let's see, it's going to be 800. And let's see, 175. I'm sorry, 8 times 100, 800. And then we have, that would be 600 then, right? So 1400. Hope I didn't make any mistakes. Okay, this one's a little more difficult for me. 2100 and 420. What does it give me? 2520. Cross that out. Let's see, 16 times 70. 6 times 7 is 42. 7, 11, 1120. Five times 20 is 100, not bad. All right, let me get my eraser out. And I think I want to do the arithmetic. You know what? I'll leave it as an exercise. This is the arithmetic. I do have it written over here. I'm hoping when the dust settles, you get this, and 10 2/3. I want to point out this is a money issue. So 10 2/3, and these are in US dollars, would be $10. And 2/3 is going to be 0.666. That repeats forever. So if you're going to round it off to the nearest cents, that would be 67, all right? Which I think is the appropriate answer, by the way, all right? Not saying 10 2/3. All right, the only thing I didn't do in the problem is the arithmetic. I'm hoping you can do that arithmetic and verify what I said is correct. Thank you.